Good morning, Algebra. We're going to do a lesson on using the distributive property to factor. This is section 5 from chapter 8, and I have to say that there are at least 3 good topics in here. So put on your thinking cap, and we're going to get going. Okay? First thing I want you to think about is we've already talked about using the distributive property to multiply things. If you had 2x and you multiply by y plus 1, you know that you just multiply that times the first and that times the second. So you get 2xy plus 2x. Well, now what they're going to ask you to do is to factor. In other words, to simplify this using the distributive property. So let's not look at the top one. And what they're going to ask you to do is kind of working that backwards. We used it to expand a problem, and now we're going to kind of go back. So look at this and see if there's anything in common. And really the best way to think of it is the greatest common factor. Well, you see there's a 2 in common in both of them. Is there anything else? Well, probably you can think back from when we just did the distributive property. You can see that there's also an x in common. So what we're going to do is we're going to factor that out. In other words, we're going to divide each term by that greatest common factor. And so this time when we write it, we're going to take out the greatest common factor, which remember was 2x. And then we take the first term and we divide it by 2x. Can you almost see it right here? That's going to, 2 over 2 just becomes a 1, x over x becomes a 1, and what are we left with? We're left with y. And then we're going to do the same thing. We're going to divide 2x by 2x. And when we do that, you can see that becomes a 1, and we have the sign of addition. So, factoring this using the distributive property gives you that. Think about it, just try to get that clear in your head. I started with the example of starting with this lower problem and expanding that out and getting this. Well, now what we've done is we've taken the longer form and we've simplified it back. We've taken out the greatest common factor, so it's like we did the inverse of the distributive property. Let's try another one just so you can make sure that you got it. Let's say it was 6y squared plus 3y, and I ask you to factor that. Okay, so why don't you go ahead and try it. Stop the tape. I'm serious. All right, go ahead and try. Okay, so let's look at this. What's common? Not a 6, but a 3 is common to both of them, and also a y is common to both of them. So let's factor out 3y. When we divide the first term by 3y, 6 divided by 3 is going to leave you 2, and y squared divided by y is going to leave you a y. When we divide the second term by 3y, that simply turns into a 1, and we're left with 1. The great thing about these types of problems is you can automatically know whether you're right or wrong. All you have to do is check it. When we do the distributive property back, does it give us this? 3y times 2y gives you 6y squared. 3y times 1 gives you 3y, so you know you did it right. Okay? That's the first part of this section. The second part of this section, I have to say, at first glance, it's a little more confusing. They're going to give you, for instance, like 4 numbers. Let's see. Example 2 says 4QR plus 8R plus 3Q plus 6. Now, when you look at that horrible looking thing, you just want to throw your hands up at first. There's nothing really in common in all of them. But if you do kind of a two-step approach to this, it's called factoring by grouping, we can factor this also. So the first thing I'm going to ask you to do is group a couple things together like in pairs that have something in common. It really doesn't even matter almost what it is. Do you see that there is an R and an R in common and also a 4 and a 4 in common? So let's group these first two together. 4QR plus 8R is going to be our first grouping. And that leaves us something that has something in common. It has a 3 in common there, so that's okay. So 3Q plus 6, we're going to group those together. So that's your first step. Group pairs together, or I guess it could be more than a pair, but it's usually going to be pairs, I think, in this section that have something in common. So we've done that. Let me tilt this down, make sure you can see. Now, second step, factor out what's in common, like we just practiced about the distributive property. Do you see that there is a 4 and an R in common in these two terms? So we're going to factor out 4R, and what does that leave us here? It leaves us a Q. And when we divide 8R by 4R, it leaves us 2, correct? Let's look at the second one. What's in common here? There's a common 3. So we're going to factor that out. And when we divide 3Q by 3, it leaves us a Q. And 6 by 3 leaves us a 2. Now look at this one. I know it looks a little more complicated than you're used to, but we have something being multiplied by something else, and something being multiplied by something else. And in this case, that is a common factor. Do you see that? The Q plus 2? It's larger than when we looked up here, we saw there was a common 4 being multiplied by this and a common 4 being multiplied by this. I know it's larger, but it's the same principle. This now becomes a common factor. So we're going to pull that out. We're going to take that out. It becomes Q plus 2. And when we divide this whole term by Q plus 2, it leaves us 4R. When we divide this whole term by Q plus 2, it leaves us a 3. Positive 3. And so our ultimate goal, or ultimate endpoint, is we get this binomial times this binomial, and if you multiply this together, it's going to give you back up here. Okay? All right. There's one more point I want to make on this, and that is, I'll start with this original thing. Actually, here's the answer. Okay? And I'm going to erase this middle part. So this is the answer we got from doing it the first way. Now, if you look back up here, don't get too concerned about the things that you group. We grouped these first two and those two. But you can group anything as long as they have something in common. What if we did 4QR and we grouped it with 3Q because there's a common Q? So let's try that. 4QR plus 3Q. And that leaves 8R and 6. Is there something in common there? Yeah, there's a common 2, right? So we're okay then. 8R plus 6. Now, our first step, remember, was we needed to factor out something in common. So we have a Q. So let's factor out Q. And that leaves us 4R plus 3. And we have a common 2 here, so we'll factor that out, and that leaves us 4r plus 3. Now, if you look at this, do you see that we have a common 4r plus 3? If we factor that out, it's going to leave behind this cube and this plus 2. And you see we end up with the same exact endpoint. So we factor out 4r plus 3, and it leaves us behind q plus 2. Okay, I think that part's going to need some more practice, but that's okay. We'll do that in class. This is just a little more complicated factoring things out. Last thing I want to mention to you is what's called the zero product property. It's kind of fun to say. Zero product property. Let me write something on the board for you here and just have you look at it. Ponder. Let it sink in. Okay, what can you tell me about X or Y? Well, since you're in video land and I'm here, I can't really hear you. I hope what you're saying is that one of the two has to equal 0. You see, it doesn't work like sometimes people say, oh, well, one has to be very big and one has to be very small. But think about that. That does not work. If this was a billion and this was a billionth, when you multiply them together, do you get 0? No, it doesn't work like that. The only way that if you have two numbers multiplied together and they equal 0 is one or both of them has to equal 0. There's no other way around it. So the zero product just basically says, if you have x, y equals 0, then either x equals 0, y equals 0, or both equals 0. Now, again, at first glance, this doesn't seem that handy, but we're going to use it to solve, to find answers to what the variables are. So let's say they gave you something like this. X plus 1 times x minus 2 equals 0. Well, look at it and you can see that if two things are multiplied together and they equal 0, then either x plus 1 equals 0, or, can you see this very right? X minus 2 equals 0. And once we have that, we can solve this. Take the 1 over to the other side. X equals -1. That's one possible answer. Take the 2 over to the other side. X equals 2. That's another possible answer. So my answers for this are x equals -1 or x equals 2. And if you want to, just plug them in. Plug in -1. If I put in -1 there, this turns out to be 0. It doesn't matter what this turns out to be because 0 times whatever is going to give you 0. If I plug in 2 here, 2 minus 2 is going to be 0. It doesn't matter what this is because that 0 times whatever is going to give you 0. So there's the zero product property. We'll use it more, but I just want you to be aware of what it is. Okay? All right, that's all.